everyone. I am K. Narsimurthy, working as an assistant professor in the Government First Grade Women's College, Tumkur. I am going to present a video for the course BSc and the subject is physics. The topic comes under the paper semiconductor devices, digital electronics, laser and fiber optics. The topic which I am discussing today is half subtractor and full subtractor. So our learning objective is to analyze the half subtractor as well as full subtractor. The half subtractor is a logical circuit with two inputs and two outputs, and this performs subtraction of 2 bits at a time. Okay, so you can only do the subtraction of 2 bits at a time. Producing difference and borrow is called half subtractor. That is the precise definition of half subtractor. I'll repeat, half subtractor is a logical circuit with two inputs and two outputs, and that can do the subtraction of 2 bits at a time, producing a difference and a borrow is called half subtractor. Okay, the two inputs are A and B, where A is called minand and B is called subtrahend. These are the two inputs, and the two outputs are, one is difference, another one is borrow. Borrow can be represented by W also. Sometimes we represent by C and sometimes we represent by W also. So before going to the half subtractor circuit and the truth table, we should understand some of the few very basic binary subtractions. As we already know in my previous video, I have taught you the subtraction of 2 bits. Means in 2's complementary method we learned the subtraction. Here also we learn a few simple subtractions. Okay. Alright. 0 minus 0 will be 0. 0 minus 0 will be 0. Here the difference is 0 and we are not taken any borrow here. So borrow will also be 0. Okay. Right. We look at the second case. In this case, 1 minus 0 is 1. 1 minus 0 is 1. It clearly shows that the difference is 1 and we haven't taken any borrow here. So borrow will be 0 in this case. Look at the other case. This is a different case. 0 minus 1. You cannot do 0 minus 1. You have to take a borrow from this previous digit. If you take a borrow from there, this becomes 1 0 and 1 0 minus 1 will be 1. Okay. Now the difference is 1 and we have taken the borrow here. The borrow will also be 1. So difference is 1. Borrow is also 1 in this case. And the last case is 1 minus 1. As we know, it is easily going to be 0. We have not taken any borrow here for subtraction. Therefore, borrow W is also 0 and difference is also 0. These are the 4 simple basic subtraction we should learn before going to the logic circuit of an half subtractor. Yes. Now, just I analyze this 0 minus 0, we got the difference 0 and the borrow 0. 0 minus 1 is a special case where we have to take a borrow from the previous stage. If I take a borrow, it becomes 1 0. 1 0 minus 1 is difference 1 and the borrow we have taken, it is also 1. And 1 minus 0, it is very much clear, difference is 1 and borrow is 0. And 1 minus 1, it's clear, it's borrow 0 and the difference is also 0. This is the table. This is the truth table with the 2 inputs and the corresponding 2 outputs, which are called difference and the borrow. Now with this truth table, we can build a logical circuit. First we build a logical expression by SOP method, sum of the product method. As I taught you in my previous video, how to build a logical expression with an SOP method by finding the minterms. So the same procedure will follow here in this difference column, in this output difference column. First identify the ones in the output difference column and look at the input combinations which produces these ones and write the minterm for this. So A is 0, obviously it will be A bar dot B. So this will be A bar dot B. And the second case will be A B bar. Second case will be A B bar. This will be A bar dot B. You have to sum all the minterms. We have only two terms over here. So we have to sum these two terms. So this becomes A bar B plus AB bar. That is the logical equation for the difference output. So that's why it's written over here. D equals A bar B plus AB bar. All right. So now the next column. So next column will be the borrow column. So if I look at the borrow output column, we have only one combination of inputs for which the borrow is 1 and that combination is 0, 1. So here if I write a minterm for this, if A is 0, so you have to write an A bar for this, A bar dot B. So A bar dot B will be the minterm for this and we don't have any other minterm to sum this. So this will be the logical equation for the borrow. So borrow we are written C over here, no problem. Either you can read it as C or you can take it as W. It is nothing matters. It's only a symbol. This is the borrow and that is equal to A bar B. Okay, we got the two equations. One is for the difference, another is for the borrow. The difference equation clearly shows that clearly demands an XOR gate, two input XOR gate. And this borrow, of course, we have to do little bit this thing. We have to NOT this A input. For that, we require a NOT gate, and also we require an AND gate over here because it's a product. So product means we require an AND gate. It is A bar here and B here. If I do ANDing, if I do logical multiplication with this AND gate, you will get a desired equation for the borrow. Okay, so here you get A bar B, and it is very much clear that you need an XOR gate, two input XOR gate to produce the difference. So this is the two input XOR gate. With this kind of arrangement, we can produce the difference and the borrow, and this logic circuit is called half subtractor because this will produce two inputs. One is the difference, another is the borrow, which performs subtraction of two bits at a time. Okay, so this is the logical circuit, and this circuit is called half subtractor. Okay, we move on to the full subtractor because this half subtractor will only do the subtraction of two bits at a time, but in sometimes we require the subtraction of three bits. So in which case we require the subtraction of three bits? Of course, in doing the subtraction of binary numbers, we come across a situation where we have to take the borrow from the previous stage. If I take a borrow from the previous stage, that is from the least significant bit in a binary number subtraction. If I take a borrow from the previous stage, now the numbers becomes 3 here. 2 is already there. We have taken a borrow from here. So now it becomes 3 over here. So for the subtraction of 3 bits, you require this full subtractor. Okay. So full subtractor is required in a case of taking a borrow from the previous stage. So full subtractor is a logical circuit which performs the subtraction of 3 bits or multiple bits at a time, which produces the two outputs. One is difference, another one is borrow. Okay, that is the way we can define the full subtractor. I'll define the full subtractor once again. Full subtractor is a logical circuit with the two inputs and performs a performs the subtraction of 3 bits at a time, produces the two outputs, difference and the borrow. So here the two inputs are A and B, sorry, three inputs. Here it is three inputs. Three inputs are A, B and C. A is called minor hand then B is called subtrahend, and C is the borrow which is taken from the previous stage. And as we know, the two outputs are the difference and the borrow. Okay, so you have to be careful here. Here we have three inputs and two outputs. We move on to this truth table. Truth table which has three inputs and the corresponding output column over here. One is the difference, other one is the borrow. As we all know, if we do that, we'll get 0, 0 here. If I do 0 minus 1, 0 minus 1, it will be 1. C1, C in is this thing. Okay, these are the required difference and the output now. Now the challenge is to build a logical circuit which suits this difference column and the borrow column. Okay, all right. So again, we have to go for an SOP method. Again, we have to identify the ones in the output and write the respective min term for that. So we have a 4 ones over here. Okay, for this one, it is 0, 0, 1. It is A bar, B bar, C. And there is one more here. It is A bar, B, C bar. There is one more here. It is A, B bar, C bar. Like this, we have to write all the min terms and we have to sum all the min terms. We get 4 terms over here. And after doing a simplification using Boolean algebra and that too by De Morgan's theorem, we come across this kind of the result over here. The difference will be C in XOR A, XOR B. It is very much clear that to produce this, we require a 3-input XOR gate. Of course, we'll do our work with a 2-input XOR gates by doing some of the combinations over here. We'll do that. We'll come to this borrow column over here. Borrow column here, 1 is here. For that, I can write this. And if I do all the simplification, after all the simplification of the min terms, summing of the min terms, and then doing the simplification using Boolean algebra, we come across this equation. You will get this simplified equation after doing a simplification with the De Morgan's theorem and the Boolean algebra. Okay, so here I am getting a very precise equation: A bar C plus A bar B plus BC in. All right. With these two outputs, now the challenge is to build a logic circuit for this. Okay. So here it is 1/2 adder. Look at this very clearly. There is an XOR gate over here, NOT gate and an AND gate. Okay. This is 1/2 adder. Sorry, 1/2 subtractor. This is 1/2 subtractor. And here there is another XOR gate, another NOT gate and an AND gate. This is another half subtractor. We have two half subtractors and output here is given to 2-input OR gate, and of course the second XOR gate output will be the difference. Okay, so to produce a full subtractor, we require two half subtractors and an OR gate. That is enough to produce a full subtractor. Finally, full subtractor is a logic circuit which performs subtraction of 3 bits at a time and produces the two output. One is the difference, another one is the borrow. Okay, all right. Yes, we understood half subtractor and the circuit diagram and the truth table. Along with that, we also understood the full subtractor with the circuit diagram and the truth table. You have to practice these circuit diagrams many times so that you may not get confused in the exams. And these are the references which I have referred, and I suggest you some of the good electronics books here. There is one good old book. It is named Digital Principle and Applications by Malmio and Leach. This is a very old book published in 1991. Of course, we have a college physics book here, and this is written by the Sundararajan and the title College Physics. We have Fundamental Principles of Physics by Basudev Ghosh, and Tumkur University people also written a good book named Fundamentals of Physics. course, in the internet also you get a lot of sources regarding this digital electronics, but you have to be very careful, sir, which is true and which is wrong. You have to segregate it, and you have to take whichever the element you require for your syllabus. But you have to be very careful in segregating the things in the internet, because whole lot of things are available in the internet. You have to be specific that which thing is required for your syllabus. Thank you very much.